Today we're on pages 72 and 73 of our textbook. We'll be putting our exponential properties to practice today. And the first four problems looks like we have to multiply. Well, let's look at a simpler problem. Let's take two fractions, say 3/4 times 4/15. To multiply two fractions, we would multiply the numerators. 3 times 4 is 12, and multiply the denominators. 5 times 15 is 60, and then reduce this. Well, 12 actually goes into 65 times, so this would reduce to 1/5. That's one way of getting our answer. But another way is we can divide out common factors. That are shared by numerator and denominator. So we can divide out common factors that are shared by numerators and denominators. In this case, we have our 3/4 times 4/15. This 4 in the denominator can divide out with the 4 in the numerator, and they be replaced with 1 because 4 goes into 4 once, 4 into 4 once. And the 3 goes into 15 5 times. And now when we multiply across, 1 times 1 is 1, and 1 times 5 is 5. So we have our answer 1/5. So this can be applied to expressions like this. We want to multiply these two fractions here, or these two expressions in the form of fractions. We can do just that, like the 4 and the 12 can reduce. 4 goes into 4 once, 4 into 12 3 times. This x in the numerator can divide out with that x in the denominator. And this y in the numerator can divide out with this y in the denominator. So we have left x to the third over 3y squared. Or I could have left things as they are and just multiply across. X to the third times x is going to be x to the fourth. So we have let's try this. 4x to the fourth y divided by 12x y to the third. And now 4 and 12 reduced to 1/3. X to the fourth divided by x is x to the third. And y divided by y to the third, subtract those exponents, is y to the -2. So this is also a correct answer, which is equivalent to this. So it's whatever you're comfortable with, whatever your preference is. Okay, so number 2, I'm going to first reduce the numbers here, like the 3 goes into 12 4 times, and then the 4 goes into 8 twice, and the 2 goes into 6 3 times. And now let's suppose I multiply across. I have y to the -4 over 3y to the -3 plus 1 is going to be -2. And now we're subtracting our exponents. -4 minus -2 is going to be -4 plus 2, which is -2. So that would be 1/3 y to the -2 can take this and bring it down into the denominator, 1 over 3y squared. These are equivalent. And number 3, the 2 goes into 20 10 times. And perhaps that's all I will do for now. Let me multiply across. So we have 10 y to the 24th, nope, sorry, y to the positive 4, x to the positive 14, divided by x to the third times x is x to the fourth, which is equal to 10 x to the 14th divided by x to the fourth is x to the 10th, y to the fourth. So 10x to the 10th, y to the fourth. Number 4, take care of this being raised to the power of 2, so we distribute. 7 raised to the power of 2 is going to be 49. Change colors. X to the power to a power we multiply, negative 6. X to the fifth times x to the first is x to the positive 6. And when multiplying, we add exponents. The negative 6 and positive 6 combine to be 0. So this is simply equal to 49x to the 0, which is 49. More practice. Here we have write the expression without a denominator. Okay, so 4a squared b divided by a to the fourth. We're just going to subtract the exponents here for our variable a. So 2 subtract 4 is negative 2. So 4a to the negative 2b. And number 2, 4a squared b divided by a to the negative 4. Subtract 2 minus negative 4. It's going to be 2 plus 4, which is 6. So 4a to the 6b. For the next 4, we want to write the expression using only positive exponents. Okay. Well, let's just take this negative exponent and bring it down. So this would be 3 over x to the positive 3, y to the positive 3. In number 4, got a lot more variables here, so maybe we'll just actually try to simplify by doing the division. X squared divided by x to the negative 3. We're going to subtract our exponents. 2 minus negative 3 is 2 plus 3, which is 5. So that's 5x to the fifth. Y to the first divided by y to the sixth. 1 minus 6 is negative 5. And z to the negative 6. Alright, and now I'll take care of my negative exponents by just bringing them down into the denominator. So this would be equal to 5x to the fifth divided by y to the positive 5 and z to the positive 6. Number 5, 4 divided by 2 is 2. A to negative 2 divided by a to the positive 3. Negative 2 minus 3 is negative 5. B to the first divided by b to the negative 3. 1 minus negative 3 is 1 plus 3, which is 4. And negative 7 minus negative 7 is 0. So this is 2b to the fourth over a to the fifth. Remember, anything raised to the power of 0 is 1. Next, with number 6, 30 divided by negative 15 is negative 2. Negative 5 subtract negative 2 is going to be negative 3. And 5 subtract 3 is 2. And just bring this down. So negative 2y squared over x to the positive 3. Describe the mistake. Negative 2 squared times negative 2 to the power of 3. Okay, so we just copy the base. This should be negative 2 raised to the power of 5, not positive 4 raised to the power of 5. The negative 2 is considered a base, and we just want to copy or carry over the base. Here, when we're dividing, we subtract the exponents. So this should be x to the 6th. And here, when we're multiplying, we add the exponents. This should be x to the 7th. Evaluate each function for the given value. Don't use a calculator. Okay, well, first off, we have f of x equals x to the negative 3 times x to the negative 1. We want to evaluate f of 2. Well, first let's simplify this. What does this equal? This equals x to the, add those exponents, negative 3 plus negative 1 is negative 4. And then if I wanted to, let's write this using a positive exponent. That's equivalent to 1 over x to the positive 4. Now, evaluate f of 2. So f of 2 would equal 1 over 2 to the positive 4, and 2 raised to the power of 4 is 16, so 1/16. Number 2, f of x equals 2 times 2/3 to the negative x plus 4 times 2/3 to the negative x. Okay, so it's these here, same, what we call base, right? So these are like terms, right? Same base raised to exponents here. So these are like terms, same exponents. So let's just add these. This would be 6, right? 2 plus 4 is 6. We would add the coefficients times 2/3 to the negative x. Let's take care of that negative exponent by flipping the fraction. So we've got 6 times 3/2 raised to the power of x. Now substitute 1 in for x. That's simply 3/2. And what is 6 times 3/2? That's 18 divided by 2, which is 9. Now you didn't have to simplify first like I did. Right? We could have just put the negative 1 in. So that would be 2 times 2/3 to the negative 1 plus 4 times 2/3 to the negative 1. So the negative 1 means we'll just flip our base there. And 2 times 3/2 is 3. And 4 times 3/2 is 6. Okay, the next one, I see like terms inside parentheses here, so I'm going to combine those like terms. So 3 plus 6 is 9. x to the negative 2 raised to the power of 3. And let's distribute. This would be 9 to the power of 3, x to the negative 6, right? Power to a power we multiply. Okay, and now one more thing. I think I'll write the 9 to the power of 3 over x to the positive 6. Now evaluating, 9 to the power of 3 is 9 times 9 times 9 over negative 3 to the 6th. Alright, let's see this. Again, I'm not supposed to use a calculator here, so negative 3 to the 6 would be negative 3 times 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 negative 3. Okay, well, negative 3 times negative 3 is, that's 9, and this is 9, and this is 9. So now these divide out, and when everything divides out, our answer is 1. Number 4, it's a little more complicated. There's no like terms here in the numerator, and there's a plus sign there, so there's no simplifying that I'm going to do here, other than x to the power of 0 is 1. Okay, this here is equal to 1. So we have simply 2 plus x to the negative 2 divided by x to the negative 1. Let's substitute in, see what we get here. So this is 2 plus 2 to the negative 2 divided by 2 to the negative 1. Well, 2 to the negative 2 is the same as 1 over 2 to the positive 2. 2 to the negative 1 is the same as 1 over 2 to the positive 1. So we've got fraction in the numerator, fraction in the denominator. So this is 1/4. So I have 2 and 1/4. 2 plus 1/4 divided by 1/2. I think I would have quit here and used a calculator. So this is 2 1/4, 2.25 divided by 1/2, 0.5. I'm switching to decimals. And 0.5 goes into 2.25. 4.5 times 50 cents. Yeah, 4.5 times. Well, let's try this. Whenever we divide, we have to divide by a whole number. So I'll move that decimal point over once. Do the same there. 5 goes into 22. 4 times is 20, and then 5 into 25. Yeah, 4.5. That was much tougher. Okay. And our last set here, we're simplifying. Ooh, they look complicated. So here, there's a couple of things you can do. You can either just first try to simplify what's inside parentheses. All right, simplify this division here. And then distribute the exponent. I think that's what I'm going to do. So 4 divided by 2 is 2. 4 subtract negative 1 is going to be 5. And 2 subtract 7 is negative 5. And z to the negative 1 stays. And now distribute the negative 3. So this would be 2 to the negative 3, x to the negative 15, y to the positive 15 because you're multiplying, and z to the positive 3. This is an answer. This 2 to the negative 3 is the same as 1 over 2 to the positive 3, which is 1/8. X to the negative 15, y to the positive 15, z to the positive 3. So this is one answer. Or if I want only positive exponents, this x to the negative 15 would be brought down into the denominator, and these two would stay as the numerator. So y to the 15, z to the third, over 8x to the positive 15. Okay, now this next one, same thing. Well, there's not much to do here, actually. So I think that I'm going to switch this to a positive exponent. I'm just going to flip this, right? I'm going to flip this. So this would be 25 over negative 5, a to the negative 2, b to the negative 1c, all raised to the positive 2. And then I believe I'm going to move these up. So this would be 25 a squared b over negative 5c. This whole thing would be squared. And now distribute. So this would be 25 squared a to the 4th b squared over negative 5 squared c squared. Negative 5 squared is 25. That would divide out with one of those two, leaving that with a 25 to the power of 1. So it looks like I have 25 a to the 4th b squared over c squared. So this is one answer. Or if we want it so that there's no denominator, we would simply move this up into the numerator, giving it a negative 2 for an exponent. So, or 25 a to the 4th b squared c to the negative 2.